guys, welcome to part 3 of our macromolecules lesson. We're going to talk about proteins last but not least. So grab the note and we'll jump right in. So proteins are the most diverse of the macromolecules. They really do so much in our cells. They can provide structure and strength. They can control chemical reactions, and that's mostly enzymes, which are a type of protein. They aid in the immune system. If you think back to our pathogens and diseases unit where we talked about antibodies are made of proteins. They do a lot. That's a very short list compared to the vast number of things that proteins do in our body cells. But basically, proteins are made up of small subunits called amino acids that are held together by peptide bonds. And proteins are made by the ribosomes in our cells. So they go through this process called protein synthesis. They're coded for in our DNA, and our ribosomes create all of these different proteins that can do all these great functions for our bodies. So amino acids are small molecules that contain a carbon atom and a side chain. There's 20 different kinds. There's 9 that are considered essential because we cannot produce them. So we can produce some amino acids in our bodies, but there's 9 of the 20 that we cannot. And so they're called essential because we have to eat them. We need to be consuming those in our diets. Otherwise, we could have a shortage of those amino acids and we may not be able to properly build the proteins that we need in our bodies. So the order in which amino acids are joined together and the folding process will determine the shape and function of a protein. So it's kind of this long list of amino acids in order, and that order is what makes all the difference. That's what actually tells the protein what type of protein it's going to be. So there's all the 20 amino acids. You guys need to memorize and be able to draw every single one of those. I'm totally kidding. Please don't do that. But that's the 20, and so of those 9 we need to get from our diets. Okay, we're going to watch another short video about how our bodies digest proteins.
It's protein time, baby. So how does the body digest and absorb all the protein molecules we get from food? Before we get to that, let's do a quick review of proteins. Without going in depth, proteins are large molecules made up of amino acids. Amino acids are linked together by peptide bonds to form a polypeptide chain. And some proteins are single polypeptide chains, and other proteins can have folds and many polypeptide chains linked together.
There are 2 main places that protein digestion takes place: in the stomach and in the small intestine.
Once the protein molecules are swallowed and enter the stomach, chief cells in the stomach release the enzyme pepsinogen. Pepsinogen is an inactive enzyme because if it were active in the cells, it would destroy proteins located inside the cells. Hydrochloric acid released inside the stomach causes a low pH level, and this actually activates pepsinogen to pepsin. And it also denatures the proteins or changes the shapes of proteins, causing them to unfold.
Pepsin breaks down the proteins into smaller fragments. So next, the food or chyme enters into the small intestine from the stomach. The higher pH of the small intestine inhibits pepsin from further breakdown of the partially digested protein. However, there are 3 enzymes that are released by the pancreas into the small intestine that do continue digestion: trypsinogen, chymotrypsinogen, and procarboxypeptidase. All 3 of these are inactive when released. An enzyme called enteropeptidase is released by the small intestine, and this enzyme activates trypsinogen to trypsin, which in turn activates other trypsinogen into trypsin, and chymotrypsinogen to chymotrypsin, and procarboxypeptidase to carboxypeptidase. Trypsin and chymotrypsin act on bonds between specific amino acids within the partially digested protein, breaking them into smaller peptide fragments. Carboxypeptidase can only act on a specific end of a fragment, breaking the bond and releasing one amino acid at a time. So, at this point, there are free amino acids, dipeptides, which are 2 amino acids bonded together, and small peptide fragments. The brush border or microvilli, which are tiny hair-like projections located on the enterocyte cells of the small intestine, also contain enzymes that finish the breakdown process. The brush border enzyme dipeptidase breaks the bond between dipeptides, and aminopeptidase acts on a specific end of a fragment, releasing one amino acid at a time. Free amino acids are then absorbed into the intracyte cells through membrane transporters within the membranes of the cells. Some di- and tripeptides are also absorbed into the intracyte cells through specific membrane transporters, where they are then broken down into free amino acids. On the other side of the intracyte cells, the amino acids are transported out of the cell into blood, where they then travel to the liver. Some of the amino acids will be taken up by liver cells, some will be used by cells throughout the body as building blocks of new proteins, and if there are excess amino acids, they can be converted to glucose, or they can be broken down and used as fuel for cellular respiration. Alright folks, so that'd be the basics on the digestion and absorption of proteins. If you have any comments, you can leave those down below.
Okay, so again, that was kind of complex. You guys do not need to focus on all of those enzyme names. We don't need to know all those. So let's break down exactly what you do need to know. Firstly, well, the one that we've talked about before is pepsin, and that's in the stomach, and that helps to start to break apart proteins into smaller pieces. Then we've got different enzymes secreted into the small intestine that is going to break apart those proteins even further. The goal is to basically end up with just a bunch of amino acids. So those pieces, or amino acids, or some dipeptides, and he was saying in the video, there's some bigger pieces that get through, but mostly just amino acids, are going to be absorbed right through the villi into the bloodstream. So proteins are just like carbohydrates in that they're going to go basically pass right through and go right into the bloodstream. Lipids are the only weird ones. So once they're in the bloodstreams, they can be transported to different body cells. So we're going to use those amino acids in our cells to create our ribosomes in our cells are going to use those amino acids to create new proteins that are needed for different functions in our cells. And then if needed, amino acids can also be converted into glucose to provide energy. So basically we have this connection between all three of our macromolecules that we've talked about, carbs, lipids, and proteins. They can all be converted into glucose to provide energy. Some just require more of a process than others. It's much more of a process for amino acids and lipids to be converted than it is for carbs to be converted. So where do proteins come from? First of all, I'm going to create two sections here. So we have to differ between something called a complete protein and an incomplete protein. And so a complete protein is something that contains all 9 essential amino acids. Remember, that's the type that we can't make ourselves, that we have to get from our diet. So if something that you're eating contains all 9 essential amino acids, it's considered complete. And so these are things like meats and fish that typically will have all 9 essential amino acids. And then something that does not contain all essential amino acids, it may have some of them, but if they don't have all 9, it's considered a they don't. So this is a consideration for people who choose to be vegetarian or vegan, is that you need to make sure that you're having a diverse enough diet of incomplete proteins to ensure that you're getting all 9 essential amino acids, because we do need all of them. So you just have to make sure that you're kind of switching up your diet, making sure that you're getting each of those from whatever sources you choose that are not meat products. And that brings us to the end. We have gone through all 3. I know that that was a lot of information this week, so take your time, maybe watch these a couple times. But I hope that all makes sense. And as always, if you guys have any questions for me, please feel free to email me, or we can set up a Google Meet. Have a wonderful day.